My name is Selin ALTUN. I'm a student at the Department of Electrical and Electronics Engineering at Bilkent University. In this video, I'll be presenting my Physics 101 project, which is about the relationship between launch angle, initial velocity, and range. The theoretical background of the formula that I will be questioning in my experiment comes from a series of kinematic equations. When observing projectile motion, it's highly encouraged to observe the motion on the y-axis and the x-axis separately. Therefore, at time t, the component of velocity on the x-axis and the y-axis can be found by these given equations. We know that during projectile motion, when the object reaches its maximum height, that the y component of its velocity is equal to 0. Therefore, when we place this value, we can find that the duration for the object reaching its maximum height to be found with this formula. We also know that since projectile motion is a bilaterally symmetric motion, that the total amount of time should be equal to double the amount it takes for the object to reach its maximum height. We can see that there is zero displacement on the y-axis, therefore the total displacement of the object should be equal to the displacement on the x-axis, which can be found by multiplying the velocity with time. Using this mathematical model, we expect the range to be found with this equation. My experiment aims to determine the accuracy of this equation that we just found by using all these formulas. The setup of this experiment consists of a projectile launcher and a ball of appropriate size to load it with, a mat, a selection of rulers, a chronometer, and carbon paper. As you can see from this demonstration, with this setup, we can pinpoint the exact landing point of the ball for accurate measurements. To determine the initial velocity, I launched the ball from a 45-degree angle a total of 3 times. By using the average value of time and range, I was able to calculate the initial velocity of the ball to be approximately 4 meters per second. With this information, I made predictions of the ball's range using the theoretical formula in question. To check the accuracy of my predictions, I repeated the same process by launching the ball from different angles multiple times and measuring its range. Comparing the predicted range and the average measured range, we can calculate the average percentage error to be overall 5.64%. While I tried my best to minimize any cause of error, there were some reasons to expect a certain amount of error to occur. In addition to any type of human error, there were numerous other causes stemming from the projectile launcher itself. Here are some examples. The inaccuracy of the rope to determine the angle. The leveling of the projectile launcher to the flat surface differs during experiments, and the displacement of the projectile launcher play a role in the error that had occurred. To conclude, considering that the theoretical predictions were made by completely neglecting any kind of friction, the results were more accurate than I had anticipated.